this video, we learn how to assign weight maps to the elements composing a Genoma hierarchy. First of all, let's define some weight maps for the mesh. From the statistic panel, let's select all the skelegons in the first layer and cut and paste them in layer 2. After having selected a loop on the thumb, let's expand the selection to the whole finger. Let's deselect some unwanted polygons and create a new weight map that we can call wfinger01. We can hide the polygons and proceed selecting the polygons belonging to the second finger using the exact same method that we've used for the thumb. Let's create a weight called wfinger02. And let's do the same for the rest of the fingers, and we'll have 5 different weights created, numbered from 01 to 05. Now we can create a weight for the palm. There's no need to select any polygon this time, since all the fingers should be hidden, and we have to assign a unique weight to the rest of the hand. Of course, this process may be more complex and long, especially if the model polyflow is not as regular as in this case. Now it's time to define which weight will be assigned to each bone when the rig is created in layout. Let's select the Genoma skelegons of the first finger. From the Setup menu, let's click on Set Skelegon Weight. We can now choose from the list one of the weights we just created on the mesh that will be assigned to the 3 selected skelegons. All we have to do now is to repeat the same operation for the other 4 fingers, and finally for the skelegons belonging to the palm. As you can see, in this case, even if some connectors or green orientation controllers are selected during the weight assignment operation, there will not be a problem, since they do not participate to the mesh deformation. Let's copy the skelegons in layer 1 and save the object. We can now send it to Layout and create the rig, selecting Create Rig from the Genoma Setup tab. If we check any of the bones, we can verify how all the weights have been correctly assigned. Of course, assigning weight is not something needed in LightWave, but if you need to maximize the control on the mesh deformation, you may want to use them. It's possible to use them only where really needed. There is no fixed rule about it. The mesh we're using is a very simple one, still in its early modeling stage, and appears to be really flat. We can improve the model, giving it a more natural shape. We can curve the whole mesh using the Bend tool. Since any editing operation we can use on polygons can be used on Genoma skelegons as well, we can perform the operation and have the rig automatically updated. We're just scratching the surface of how powerful the Genoma rigging system can be. We can move, rotate, scale, deform, edit and duplicate the whole model in total freedom, since the Genoma skelegons will react exactly as polygons to any change. Let's save the model. Back in Layout, let's update the Genoma rig. Even the bending orientation of the fingers, whose direction is defined by the direction of the green arrows in the Genoma preset, has been updated according to the bending operation. We can take a look at the green arrow in Modeler and try to relate their orientation to the bending direction of the fingers in Layout once the rig is created. Now, let's take a look at how well Genoma deals with mesh mirroring and stretching. We can move the mesh a bit on the right side and create a symmetrical copy using the Mirror tool. Let's select the mirrored model and apply a stretch. Back in Layout, let's update the rig. We can now play with the controls and notice how they're still working without problems. This is a very cool feature, since it makes it possible to create different characters and rigs from the same base mesh and Genoma preset, simply editing the pose and proportion of the body together with the rig, without the need of readapting it. Let's take a look to another situation. What if our characters end as only 4 fingers? Of course, we can use the 5 fingers presets we already adapted to the previous mesh. You can identify them both by the shape and color. They can be orange or magenta. While you should never delete the orange ones from the scene, the magenta connectors can be deleted, and so can be what is attached to their tip. In the hand preset we have 5 of them, used to connect the wrist to the fingers. Let's select this one and delete it. We can now delete the whole hierarchy that was connected to that connector. Now we have a 4-fingered hand ready to be rigged in layout. Of course, we can apply the same bending operation we already performed on the previous model to make the hand pose more natural. In this video, we just scratched the surface of being able to model and reuse a rig. In the next one, we'll take a look at some of the available sub-rigs we can use to build complex presets, and talk about the connection rules we should follow during the process of creating a Genoma character rig.